I'm going to do sort of an express teaching. You're going to learn just the how to, don't need to know the why. Okay, the whys, we can leave that for next year. Otherwise, it will be a bit too compact. Okay, so we're going to learn the hows. The hows is just how to do it. Don't question it. Just is how you do it, and copy the technique and learn from it. Okay, so here we go. Matrices. These are called matrices. You don't have to copy these examples now, but what you do need to know is how we define them. Now, when we call them matrices, there are different sizes. Okay, this one has this kind of squarish size. It's a bit more rectangle. It's a bigger square. There's just one number there. We give them sizes. We call them dimensions. Okay, the size of the matrix is called by its dimensions. Now, how do you calculate, or how do you determine the size, or how do you tell someone what kind of size matrix you want? Is dimensions are calculated by rows, by columns. So if you have a look at the first matrix, okay, this matrix, I've got how many columns and how many rows in this case here, Ian? 2, 2. Okay, I've got 2 rows. So I've got row 1, which is the horizontal. I've got 2 rows and 2 columns. So what you would say is the dimension for this matrix is, you would say it is a 2 by 2, which means 2 rows and 2 columns. Okay? Sydney, you had a question? Yeah, these are brackets, like massive brackets. Yeah. And this numbers inside them are called entries, which I'll write here. These are called entries, and together this whole thing is called a matrix. Okay, but you have different types of matrices or different size matrices. Okay, so let's have a look at the next one. How many rows and how many columns do I have here, Matt? I've got one column, 1 row. Say it again. I've got 1 column. How many rows do I have here? 2 rows. Okay, rows is the number of horizontal lines we have. So here we've got 1 row, it's a 6. And the next row, I've got a 7. So that makes 2 rows, but 1 vertical column. They all fit 6, 7 is under 1 column. See, this one is negative 3 and 5, that's 1 column. That's 4 and 6, that's another column. So that's 2 columns. This is negative 3 and 4, 5 and 6. So 2 rows, 2 columns. So 2 rows, 2 columns. So this is 2 rows and 1 column. So we call this a matrix of 2 by 1. It's a 2 by 1 matrix. Okay. What about the third one, Sydney? How many rows, how many columns? Yeah. So we say this is a 3 by 3. It's not times, it's just by. Okay, that cross means by. So 3 by 3 matrix. So this is a 3 by 3 matrix. What about the last one? What kind of matrix is this, Anna? It's a 1 by 1. So 1 row, 1 column. Okay, so this is a 1 row by 1 column. So that's the first step, understanding matrices. Okay. Now with matrices, just like any new thing you learn, you're going to have to learn how to add, subtract, multiply. But the only difference now is you don't have divide. Okay. So matrices won't have a divider, and I'll show you why later. It's a very quick why. I'm not actually going to explain the logic to it. But you're going to learn how to add, subtract. You can learn how to multiply. That's what this exercise is about. So 70 is about add, subtract, multiply, matrices. Okay, now if you've done this in special, it would have been broken up into like 3 different exercises where you add, subtract, then you got multiply by a number, and then multiply by 2 matrices. So it's done over a few exercises. So if you've done special, you would have had a bit of practice. If you haven't done them before, then you're doing it all in one exercise. Okay, so here we go. We now know these are called matrices. We know how to determine the size of the matrix. Now we're going to learn how to add them. Now, how do you add matrices? It has to have the exact same matrix dimensions, meaning it has to be the same size. You can't add matrices that aren't the same size. Now, if you have a look at this matrix here, this is a, what kind of size do I have there, Oscar? What?
2 by 2.
This is a 2 by 2 matrix. And then I'm adding on with this other matrix here, okay, with this other matrix. What kind of matrix is this, Will? 2 by 2. Now, because they are the same dimensions, you can add them. But how do you add matrices? These are the entries. Okay, so these, one is an entry, that's an entry, that's an entry, that's an entry. You add them correspondingly. Meaning, this is the row 1 but column 1 entry. Okay, so we call that number 1 there, row 1, column 1. This is row 1, column 1 entry. You add that with row 1, column 1 of the second matrix. Okay, so that means they have to correspond. 1 plus the 2. This is row 1, column 2. has to add with row 1, column 2. That's why you have to have the same matrix. If you don't have the same size, you can't add them. They have to correspond to one another. So it's 0 with a -1, 2 with a -4, and 0 with a 1. Does that make sense? Anyone confused there? No? Okay, so this is what the next step should look like. You've got a 2 by 2. See, row 1, column 1, I have 1 plus the 2. Row 1, column 2, it's 0 with a -1. Row 2, column 1, row 2, column 1 is 2. Row 2, column 1 is -4, so I'm adding those two, and then 0 and the 1. Okay? You simplify that down, you should still end up with a 2 by 2. This is the answer. This is the answer of the first matrix and the second matrix, 3, -1, -2, 1. Okay? Now what you can see is doing matrices, one of the first things you find difficult is that when you have more matrices, it's hard to write down all of them. It gets messy. So we normally use a letter to represent the matrix. Now, how do you know if something's a matrix? The notation we use is a capital letter. You know how we did sets and notations? We use a capital letter to talk about a set. Well, you do the same for matrices. You can actually get a question where they'll say, let's call capital A, matrix A, 1, 0, 2, 0. You could do that. And you could say, let's call this other matrix B equals to 2, -1, -4, 1. And then you can say A plus B equals C. And that's much easier to write. Okay, so here, A plus B, which is what we've done here. So I've got A plus B, this is equal to C now. Okay, so it's much easier to write it with capital letters, but they just represent a matrix. Okay, so that's all I'm just saying. Just sometimes later when you're doing the exercise, you'll find that they'll use capital letters to represent a matrix just to make it easier. Okay, otherwise it looks really messy when you leave like that one. Okay, let's try the next one. What about B? If I want to solve for B now, so if I want to do B, let's look at the matrix. You always have to look at the dimensions first. So what kind of dimensions do I have here, Yasmin? What kind of matrix is this? How many rows? 2. I got 2 rows. How many columns? 1. So it's a 2 by 1 matrix. Okay. Next one, Simone. What about this one? What kind of matrix do I have? It's a 2 by 1. 2 rows by 1 column. So now they're the same matrix. Now you can add or subtract. It's up to you. Okay. So in this case here, we're subtracting. That's row 1, column 1. So in order to subtract, I'm going to make sure I subtract the ones that are in its positions. And I can see it's 2 minus 2. And then -1 minus -1. Now notice that I wrote out the negative sign so I don't make that mistake. -1 minus 2 negatives become a positive, so -1 plus 1 gives you 0, and your final answer is 0, 0. How do you feel? Easy? Sorry? Looks like a YouTube. Oh, is it? Oh, yeah, you're right too. Nutri-grain. All right, so that's how you add and that's how you subtract. So the only thing you need to know is matrices have to be the same size and you add the same entries, corresponding entries. Okay? Now, it's not that adding, subtracting is hard. It's not multiplying by a value. The hardest one, which I want to teach, is to multiply 2 matrices. That's the confusing part. But what I want you to get used to, the language I'm using, is row 1, column 1. Yeah, row 1, column 1. If you understand what I'm saying there, doing the matrix multiplication will be easy. Yeah? There we go. Let's try another one. This is multiplying matrices by a number. Scalar means number. Okay, just the value. Okay, so here we go. We've got 3, which is a number. And you write it outside the brackets or outside the matrix. That just means 3 groups of this matrix. So when you think about it, 3 groups of this matrix, it actually just means this. 3 groups means I've got 3 groups of 2 minus 2, 0, 1, which means the same thing as saying 2, -2, 0, 1, add 2, -2, 0, 1, add 2, -2, 0, 1. That's what you're essentially saying. When you say you have 3 groups, like if I said I've got 3 groups of 2, you would have done 2 plus 2 plus 2. That's why 3 times 2 is 6. Yeah? It's the same thing when you write 3 groups of this matrix. That's essentially what you're saying. You've got 1 group, 2 groups, 3 groups. But when you're adding, you see if you're adding matrices, you'll be doing 2 plus 2 plus 2, which ends up being like saying 3 groups of 2. If you do -2 plus -2 plus -2, that's the same thing as saying 3 groups of -2. If you do 0 plus 0 plus 0, it's 3 groups of 0. So instead of doing the addition, why don't we just write it like this? That's much easier. So this is when you're multiplying by a number, you can say, I've got 3 groups of 2, I've got 3 groups of -2, so 3 times the -2, 3 times the 2, 3 times 0, 3 groups of 1. That's what you're essentially saying. Okay? And so that now gives you your matrix 6, -6, 0, 3. So this is multiplying by 3, but this is the logic. That's the logic. So if you know how to add and know how to subtract, you can multiply. The multiply is just repeated addition. Okay, so 2 plus 2 plus 2 is 3 times 2. -2 plus -2 plus -2 is 3 times -2. That's where the logic is. Any questions there? How's that feel? Pretty good. So times by a number, adding and subtracting. Now, this is what I want you to do. I want you to have a go with this example. So this example here, they tell you what matrix A is, they tell you what matrix B is, and they want you to find 2 times A plus X equals B. Find X. Okay, so I want you to write it down. So we start off with 2A plus X. I want you to start off there and see if you can figure out what matrix X should be. Oh, that should be a bracket there. Is this what you meant? Oh yeah? Yep. That's a number. And that coefficient. Coefficient means 3. Okay, it's coefficient. It's like when you say 3x. That let's solve for 2a plus x equals b. Now think about it. If you were to solve for x mathematically, how would I find x? What would you have to do normally if this was just algebra? How would I solve for x?
B equals -2a.
Yeah, you would say balance the equation, get rid of the 2a. Now how do you get rid of 2a? Minus 2a on both sides. Yeah, so that's what I would do. I'd say to find out x, I would say minus 2a minus 2a. That cancels out, and now x will equal to b minus 2a. Now what is b? They told me b is 0, -4, -2, 8, so that's matrix, minus 2 times whatever matrix A is. So I'll write that down. I'm like, all right, I know what B is, I know what A is. I write it down. Matrix B minus 2 times matrix A. Now we've learned this. If you've got a 2 in front of the matrix, you can multiply the coefficient to the entries inside. So it'll be 2 times a 3, 2 times a 2, 2 times a -1, and 2 times 1. So if you do that, that's what you're going to get. 2 times 3 is 6, 2 times 2 is 4, 2 times -1 is -2, 2 times 1 is 2. Now you check if the matrix are the same size, they're the same dimensions. 2 by 2, 2 by 2. You're subtracting them. Now the only way to subtract, entries by entries. 0 take away 6, -4 take away 4, -2 take away -2, and 8 take away 2. And you get your answer. Matrix X has to equal to -6, -8, 0, 6. Okay, so I'm just following here. I said subtract minus 2a on both sides, that cancels out. X is equal to matrix B minus 2 times A. 2 times matrix A gives me this, and then subtract the 2 matrices. Okay? How do we feel? Does that feel easy? Pretty straightforward. So you're just doing add, subtract, multiply by a scalar value. Okay? So that's the first half of the exercise 7E. The last one is the last skill I want you to pick up, and I want you to copy this down. Okay, so if you've learnt this, great. It's the next slide. I want you to make sure to know how to multiply matrices. Don't question it, just do. Okay, don't question why. This is how we multiply matrices. Okay, so here we go. Multiplication of matrices. You have a couple of rules that you have to check out first before you do them. Rule number 1. In order for you to multiply, you have to have the column of the first matrix to be the same as the row of the second matrix. Okay, so I wrote that in words, but I'll show you what I mean. What I'm trying to say is when you do like a 2 by 2 and then 2 by 7, you just got to make sure that the column of the first matrix has to be the same as the row of the second matrix. So an example would be if I gave you 2, 1, 3, 4. What's the size of this matrix here? 2 by 2. Okay, so the column right now, I've got 2 columns. Okay, when I multiply that with another matrix, it can be any matrix as long as the row of the second matrix, because it is 2. As long as 2. I just need the row of the second matrix to be 2. Okay, so this is the first matrix. It's a 2 by 2. And you can see how that 2 is your column. You need the column, so n has to be the same as p. Okay, so your second matrix has to be 2. So here we can have 2 by 4 if you wanted to. 2 by 4 would mean you got 2 rows and 4 columns. So it will be like this. It will be 1, 2, 3, 4, 5, 6, 7, 8. See how I've got 2 rows and 4 columns? So that doesn't matter what this is as long as these two are the same. Row of the first one, row of the second one, and column of the first one. Column of the first, row of the second. Okay, it has to be in that order. So this times this, these two have to be the same for you to multiply. That's the first rule. Yes, Sydney? Then you can't. You can't multiply. It's just the rule. It's a fair question, eh?
No, like 3 by 2 by 2 by 2.
Oh, yeah, no, you can. Sorry, I thought you meant if that was a 3 by 2. If this is a 3 by 2 and that's a 2 by 4, fine. They will look different. They will look different. The answer will end up being different. That's rule number 2. I'll tell you what rule number 2 is after. Yeah? But rule number 1, you just need n and p to be the same. It doesn't matter what m and r is. M and r can be anything. Okay? M and r can be whatever, but p and n have to be the same. So n and p must be the same. M and r can be anything. You could have 3 by 7 matrix multiplied to a 7 by 8 matrix and it still works. That's okay. Yeah. Yeah.
It's going to be hard to tell.
Yeah, exactly. So that's why I'm just telling you the first rule. That's the first rule. Okay? Second rule. This is the second rule. So, if you want to know what the answer, if you can multiply, so if rule 1 works, okay, rule 1 is satisfied, then rule number 2 says that the row of the first matrix and the column of the second matrix will be the size of your ending result.
All right.
Okay, so that means M and R, that's the result of your final matrix. When you multiply them, it'll be the size of M and R. That's what the result will be. So in this case here, this example over here, a 2 by 2 multiplied to a 2 by 4, the answer will be a 2 by 4. Okay, because M is 2 and R is 4. So in this case here, this answer over here would end up being a 2 by 4. Whereas this matrix here, what would my answer be for this matrix? If I multiply these two matrices together, what would my result be? Not 7, 7. 3, 8. 7, 7 tells me rule number 1 works. Rule number 2 tells me that the answer will be a 3 by 8. Okay, so the 3 by 8. The two numbers on the outside will tell you the size of the final matrix. Okay, those are the 2 rules. Okay, I haven't shown you how to multiply yet. I'm just telling you the 2 rules that you have to follow first before you can multiply. Okay, so rule number 1, column of the first has to be the same as the row of the second. The result will be 3 and 8. Rule number 2. Okay. Let's make sure to copy that down. Because in the next example, that's the key. Next example, it's where it gets tricky. I'm going to try to highlight it to remind you. And you're going to try to remember row 1, column 1, row 2, column 2. Those kind of things are going to be important to understand. Yeah? All right, here we go. Let's do an example. Let's do an example. Here we go. I'm going to multiply matrix A and matrix B. That's how I get AB. Okay, AB means A times B, right? Now what I want you to see is what kind of matrix size do I have? What's my dimensions for A? What's the dimensions for matrix A? Can I please have, let's go with Trent.
2 by 2.
A 2 by 2, fantastic. I've got a 2 by 2 matrix. Now let's look at matrix B. Lauren, what kind of dimensions do I have here? How many rows do I have? 2. And how many columns? 1. So it's a 2 by 1 matrix. Okay? So now I've got a 2 by 2 times a 2 by 1. Now rule number 1, we said the column of the first matrix has to be the same as the row of the second. Yeah, so this is the row of the second matrix. Are these two the same? Yes. So rule number 1 ticks off. Rule number 2 says if you multiply these together, that tells you what the ending matrix should be. Now the ending matrix would be a 2 by 1. Okay, so it's got 2 rows and 1 column. So when I multiply this now, I know AB has to be a 2 rows. So row 1, row 2 has 2 rows and 1 column. That's what I know. Okay, so now let's try to multiply. This is where it gets tricky. Okay, and I'm going to color code so you can see. We said the answer was going to be 1 column and 2 rows. This is a 2 by 1. Okay? Now there's 2 entries here then. Row 1, column 1. Row 2, column 1. There's only 2 entries here. Okay, so a 2 by 1 tells me I'm only going to have 2 entries. So how do you work out from 2, 4, 3, 6, 5, 3? How do you get the answer to be a 2 by 1? I'll show you. And I'm going to highlight it. Here we go. This is how you're going to do it. This is row 1. Agreed? Row 1. So I highlight it in yellow. Let's highlight in green now. This is column 1. When you're multiplying, you'll be multiplying row 1 by column 1 to get the answer for row 1, column 1. Okay? So how do you multiply 2, 4, and 5, 3? It's based on its positioning. This is the first number of the first row. That's the second number of the first row. This is the first number of the column. This is the second number of the column. So you'll be multiplying the first with the first, second with the second. They have to correspond. Okay, so this is how it works. You're going to write down, and I color coded for you here. Here we go. We said row 1, column 1. Row 1, column 1 had row 1. First number is a 2. Column 1, the first number is a 5. So I did 2 times 5. Okay? So I paired 2 and the 5. And then row 1 has the number 4 as the second number. I multiplied that to the second number of the column. So it's 4 and 3. You add those two together. Okay? You add those two together. Okay, so I'm going to draw arrows so you can see. I paired 2 with the 5. I'll do it in pen. 2 with the 5, 4 with the 3. Okay, that's row 1, column 1. Whatever that answer is, that will go to row 1, column 1. Okay? Row 1, column 1. That's the trickiest part. So out of all the exercises, if you did special the first time learning matrices, this is the hardest one to learn. So understand that it's row 1 by column 1, but first term with the first term, second term with the second term. Okay, and that will give you the entry for row 1, column 1, that column. Okay, so let's work this out. 2 times 5, which we know is 10, plus 4 times 3, which is 12. 10 plus 12, 10 plus 12 will give you 22. Now, see what I'm doing here? I've just done 10 plus the 12, so 2 times the 5, 4 times the 3, gives me row 1, column 1. How do you get row 2, column 1? Row 2 is this one. That's 3, 6. So you'd be pairing 3 with a 5, 6 with a 3. 3 with a 5, 6 with a 3. See what I'm doing there? Okay, so I'm just pairing first number with the first number, second number with the second number. And then I add those two together. But that gives you the entry. Whatever you're multiplying will give you the entry. So if I rub this off and I highlight it for you again. So we're highlighting. We are doing, whoops. I'm going to highlight again. Row 2. So that's row 2. Multiplied 2. So this is row 2. Row 2. I'm multiplying it to column 1. And that's 5 and 3. So that's where my 5 and 3 are coming from. Okay? It's the first number of your row. 3 with a 5, first number of the column. Second number of the row with the second number of the column. So 6 and 3, 3 and 5. 3 and 5, 6 and 3. 3 times 5 is 15. 6 times 3 is 18. Add those two together, 33. So when you multiply 2, 4, 3, 6, and 5, 3, that's what you're going to get. Okay, so row 1, row 2, column 1. Row 1, column 1 will give you the answer for row 1, column 1. Okay, so 2 with a 5, 4 with a 3. 3 with a 5, 6 with a 3. Okay? I'll do another example. How do you feel? Be confused? Yeah? Let's do another one. Let's do another one. Let's do, just in case you still need a bit more practice here, I'll show you. Let's say I gave you 3, 2, 1, 1, 2, 1. Yeah? And I'm multiplying. So this is a 3 by 2 matrix. And I'm going to multiply this to 1, 1, 1, 1. This is a 2 by 2 matrix. Okay? So let's say I want to multiply that. So rule number 1, I have to check. Does this column match with the row of the second? Yes, they do. They're both 2s. What's my ending result? It'll be a 3 by 2. Okay, so my ending result will have 3 rows and 2 columns. 3 rows, 2 columns. So I'm going to write it out. I know the answer has to have 3 rows. So row 1, row 2, row 3, column 1, column 2. That's the result. Okay? Now, how do I find the answer? I'm going to highlight it again. So, what do we want? We want row 1, column 1. So, I'm going to highlight that. Row 1, column 1. Okay, so I'm going to highlight row 1, column 1. Does that make sense so far? So, if I want the answer to put an entry for row 1, column 1, I highlighted row 1, column 1. Now, how do I multiply it? It's the first with the first, second with the second. First number for the row is 3. First number for the column is 1. So it'll be 3 times the 1 plus 1 times the 1. Does that make sense? So the second number with the second number. And that all goes to the answer for that one spot there. So if I were to answer it now, let's work it out. I'm going to do it in red. And do it in red over here. 3 times the 1, which is 3. Add with 1 times the 1, which is 4. So 4 will go here. Okay? If I want the answer for, let's say, row 2, column 2. Let's say I want to know the answer here. Okay, I want to know what is the answer for this spot here. Then what I would do is I'll say, okay, to find out this answer, it will be row 2, column 2. So let's highlight that. Row 2, which is this one. Column 2 is that one. So you'll be doing first number with the first number, second number with the second number. So 2 times 1 plus 2 times 1. 2 times 1 is 2, plus 2 times 1 again is 2 again. So 2 plus 2, and that number has to be 4. And that will give you the entry for row 2, column 2. Okay, so I can't rub off. There we go. So this has to be 4 here. That's just me highlighting. Oh, it's not rubbing off. Okay. All right, let's practice with you guys now answering for me. Let's say I want this entry here. What numbers will I multiply? Let's go with Fib. What numbers will I multiply? I want row 1, column 2. Which numbers will I be multiplying? Row 1, column 2.
You'll do 3 times 1.
Good.
1 times 1.
Good. Okay, so you see, you'll take row 1, column 2. First number, 3 times 1, which is 3, plus 1 times 1, which is the second number. 1 times 1 is 1, so 3 plus 1, that tells me this is 4 as well. Okay, so row 1, column 2 gives me the entry for that. So this is 4. Let's do the next one. Let's say row 2, column 1. So row 2 is this one. That's 2, 2. I want to multiply it to column 1, which is this one. Okay, so row 2, column 1. Row 2, column 1. First number is a 2. First number is a 1. So 2 times the 1 is 2. 2 times the 1 again is 2. 2 plus the 2, 4. Okay, so this is the weird part, but whatever the entries are, the rows, columns, that's how you're multiplying them. Okay, so this is 4. Let's do the last one. Whoops. Let's do the last one. What about row 3, column 1? What numbers will I be multiplying here? Felix.
1.
Yeah.
1.
1 and 1. See, row 3, column 1. So I've got 1 with a 1. And then? And the 1 with 1 again, 2. So 1 times 1 is 1, plus 1 times 1 again is 1, so the answer here has to be 2. Okay, so I now know row 3, column 1 is 2. And you do the same thing for the last one, same thing. Row 3, column 2, so 1 with a 1, 1 with a 1, so it ends up being 2 at the bottom here. Does that make a bit more sense? How do we feel? Feels a bit better? Yeah? Okay, and that is the hardest part of this exercise. Okay, so if you want to really practice, the exercise or questions you want to do is this last one. These ones here. Okay, you want to practice multiplying this with this or this with that, but you have to check the first 2 rules. They have to work. Rule 1 has to work before you can multiply them. That's 7E. Okay, that's exercise 7E. So you have to be able to add, subtract, and multiply with a number, and multiply with matrices. Those are the 2 it's going to take. Okay? But 7E only has 7 questions there, so that's what I want you to practice now. Okay, only 7 questions. That's great. I want you to multiply with a number, add, subtract, and then I want you to multiply matrices. Okay? Let's go. I'm going to leave that there. I'm going to pause the video.